This is a quick introduction to the Rocket method for time series classification. Time series consists of values ordered in time. This could be, for example, financial data, motion sensor data, audio data, or data recorded over time by telescopes or Earth observation satellites. When we have a lot of time series data, a critical task is to learn to assign time series to different categories or classes. For example, we might want to identify gestures or activities based on motion sensor data, to identify different species of animal based on sound recordings, or to detect the presence of a planet orbiting a distant star based on data from a telescope. However, until relatively recently, the most accurate methods for time series classification have also been the most computationally expensive, making them intractable for larger quantities of data. And this brings us to Rocket. With Rocket, we transform the input time series using a large number of random convolutional kernels, and then use the transformed features to train a linear classifier. This allows us to achieve state-of-the-art accuracy with a fraction of the computational expense of other methods of equivalent accuracy. Convolution involves the sliding dot product between a convolutional kernel and the input time series. The convolutional output reflects the strength of the match between the kernel and the input time series at each time point. Convolution represents a single mechanism which can capture diverse features in time series, and this mechanism underlies the effectiveness of Rocket. In Rocket, we use 10,000 random convolutional kernels which are random in terms of their length, weights, bias, dilation, and padding. Kernels with different weights and different dilations capture different characteristics of the input time series at different scales. From the convolutional output, we extract two features, the maximum value and a feature we call PPV for the proportion of positive values, which represents the proportion of values above some threshold or bias value. We use a different random bias value for each kernel. In summary, we convolve our input time series with 10,000 random convolutional kernels, and we extract the max and PPV features from the convolutional output for each kernel. We repeat this process for each of the input time series. The resulting features are then used to train and perform inference with a simple linear classifier. With Rocket, we achieve state-of-the-art accuracy with a fraction of the computational expense required by existing methods of similar accuracy. Two more recent additions to the Rocket family of methods include Mini-Rocket and Hydra. In Mini-Rocket, we replace the large set of random kernels with a small, fixed set of kernels. This allows for significantly optimized computation, making Mini-Rocket almost 2 orders of magnitude faster than Rocket on large datasets. Hydra represents a hybrid between Rocket and so-called dictionary methods for time series classification. We arrange the kernels into groups and count the kernels in each group representing the closest match with the input time series. Hydra is faster and more accurate than existing dictionary methods. More information is available in the relevant papers, and you can try Rocket, Mini-Rocket, or Hydra now using the open source implementations available on GitHub.